Okay, in this clip we're going to look at moving rounding on from just working with decimal places to a different system of rounding numbers, which is known as significant figures. So just to remind you how we work with decimal places, the point to remember is that when we're rounding decimals, we start counting as soon as we reach the decimal point. So if we want to round 17.46789 to two decimal places, doesn't matter what numbers are to the left of the decimal point, the first decimal place is the first digit that comes to the right of the decimal. So that would be the first decimal place, that would be the second decimal place. That means that this number is either going to be 17.46 or it's going to be 17.47, because that number is somewhere between the two. The decision we then have to make to determine which one of these is the actual correct rounding is to look at the next digit along. So that's my cutoff. To determine that, you look at the third digit in this case. If that is 5 or more, it means that the whole number is going to be closer to the higher of those two. So because that is a 7, it means that actually, if we think of it on a number line, if I put my number line over here, 17.46 will be there. If I'm counting in two decimal places, 17.47 is there. The midpoint between the two will be 17.465. So if the number is to the right of that, it's closer to 17.47. If it's to the left of that, it's closer to 17.46. So because that is 0.7, which will say be there, so that number is going to be there, it means it's closest to 17.47. So to two decimal places we would write 17.47 and then after it 2dp for decimal places. So that's the system that by the time you get to year 11 you're very familiar with. You will have rounded to decimal places a great deal. If we end up working with very large numbers or very small numbers, rounding to decimal places isn't necessarily useful, and we'll see that with some numbers later on. When that's the case, we round to significant figures. Now the thing to remember here is we start counting as soon as we reach a number that is not 0. Same again, we're working from left to right, just as we read. So here, if we're rounding the same number to two significant figures, the two most significant figures are the two that are to the left of the decimal point. That would be the first and that would be the second. And the reason that they're the most significant, because you could argue, well hang on, that's a 9 there, surely a 9 is a more significant number than a 1. It's all to do with their place value. If you think back to primary school, when you first met decimal numbers, you were taught that that was your units column and that there is your tens column. So because that digit 1 is in the tens column, its value is 10 because it's 110. That digit there, which is the digit 7, has only got the value of 7 because it's in the unit column. The numbers this side, those are going tenths, hundreds, thousandths, so those are getting progressively smaller. So the third most significant figure in that is the 4 because it's a tenth, and so on. So when you were rounding to significant figures, you were working left to right and you're identifying the digits that are the first non-zero digits that you meet. So to two significant figures, this is either going to be 17 or it's going to be 18. And then the decision we take is similar to what we do with decimal places. We look at the next figure along. If it's 5 or more, it rounds up. If it's less than 5, it rounds down. So then we're in the same position as we are up there. If we work into two significant figures, it's either going to be 17 or 18. The trigger point is halfway between them, which is 17.5. This is 17.4, so that number is there, which makes it closer to 17. So rounding that to two significant figures, the answer is 17. So we would write it as 17, and then after it we would write 2SF for significant figures to show that that's a significant figure rounding. So that's two significant figures. Going back to the top of the page, that's two decimal places. So let's see how this develops. So rounding to one significant figure, this is my most significant figure. Now what we have here is units, tens, hundreds, thousands, 10,000s, 100,000s. Writing that as powers of 10, I know that 100 is 10 squared. So that would be 10 to the power of 1. That's 10 to the power of 0. If you get used to writing it this way, it makes standard form much easier as well. But for now, all we need to know is that this digit is the most significant because it's actually means 300,000, which means this number is either going to be 300,000 or 400,000. So if it helps you to imagine it on a number line, the trigger between the two is halfway, which would be 300,500. And we can see here that, 350,000. That's the halfway line. We look at the next digit along, which is greater than 5, so it means that this number would be that side, so around to 400,000. So 4, and then we have to put all the zeros in, otherwise that loses its place value. So a common mistake to make here is just to say, well, the answer is 4. Well, it's not 4, that's a massively different magnitude, size of number to 400,000. So it's 400,000 to 1 SF. If we round it to three significant figures, that's the first, that's the second, that's the third. So it's either 378000 to keep it in this place value, or 37900. Look at the next digit along, it's smaller than 5, so it's closer to 378. So that places it there. So 378,000 to 3 SF. To show you an example of working with small numbers, if we were asked to round this number to two decimal places, the answer would be 0, because that's the first decimal place, that's the second decimal place, which isn't particularly helpful. So with small numbers, usually it's better to work to significant figures. We work left to right, which means that's the first most significant, that's the second most significant. So my answer is either 0.002 or 0.003. We have to decide which one. Sorry, 0028 or 0029, two significant figures. So we have to decide which one of those is closest to. We look at the next one along. 5 or more means it's closer to the upper of the limits. If you think of it on a number line, the smaller value, the higher value, the middle bit, and this makes it closer to that side. So 0.00292SF. Three significant figures: first, second, third. So even though that's a 0, it's a significant 0 because it keeps these out in their place value. So my answer is either going to be 0.00208 or 0.00209. If you think of it on the number line, that's the halfway point. We look at the next digit. Next digit clearly puts it that side, so 0.002093SF. Okay, then we've got some to have a go at. So let's take a look at these. So question 1, what is the difference between rounding to significant figures and rounding to decimal places? So that's all to do with decimal places. You don't begin to count until you reach the decimal point. With sig fig, you start to count as soon as you meet a non-zero figure. So with decimal places, you don't begin to count until you reach the decimal point. With significant figures, you start to count as soon as you meet a non-zero figure. In both cases, moving from left to right. So you're starting here and counting in that direction. Question 2. Round the following numbers to 1 sig fig, 2 sig fig, 3 sig fig. So the number is 1463.8. So to one significant figure, it's this one. So it's either 1000 or 2000. We look there, that's 4, so it's less, so it's closer to 1000 than 2000. To two significant figures, it's either going to be 1400 or 1500. We look at the next value, it's higher than 5, so it's 1500. And 3 sig fig is either 1460 or 1470. That's less than 5, so it's closer to 1460. 2, 157.26. A, so it's either 100 or 200. It's closer to 200, 200. To two significant figures, it's either 150 or 160. It's closer to 160 because of that 7. And to three significant figures, it's either 157 or 158. That's a 2, so it's closer to 157. 3, 37.096. A, one significant figure, it's either 30 or 40, so 30 or 40, it's closer to 40. Two significant figures, 37 or 38. Next one's a 0, so it's closer to 37. Three significant figures, it's either 37.0 or 37.1. Look at the next, it's a 9, it's closer to 37.1. Number 4, 6.0936. One significant figure, 6 or 7, it's closer to 6. Two significant figures, 6.0 or 6.1. Look at the next one, higher than 5, 6.1. And three significant figures, it's either 6.09 or 6.10. Look at the next, it's 3, so it's closer to 6.09. And then part 5. So one significant figure, it's either going to be 0.006 or 007. That's a 4, it's less than 5, so it's 0.006. So two significant figures, it's either going to be 0.0064 or 65. Next one's a 0, it's closer to 64. And three significant figures, 1, 2, 3, so it's either 6.00640 or 641. It's closer to 640. And in that instance, we do add that 0 to show that it's the three significant figures. And then a little bit of calculator practice. So we'll use our calculator to work out these. Great calculators, you can type these in exactly as you see them. So the square root of 22, change it to a decimal, and we want these two significant figures for each. So two significant figures is 4.6 or 4.7. This one's going to round up to 4.7. B. So for this one, we want to set up a fraction. On top, 3.2 times 0.2 squared. At the bottom of the fraction, 2.3. So I've typed it in exactly as it looks there. Turn it into a decimal. So when we're rounding this to two significant figures, that's the first, that's the second. So it's either going to be 0.055 or 56. The next digit along is a 6, so that rounds that up. 0.056 to 2SF. C. Okay, so we can put this in our calculator the same. Start with the square root. Underneath the square root we want a fraction. Times 0.3 squared on top and 11 underneath. So to two significant figures, it's either going to be 0.19 or 20. Next number across, digit across, is a 0, so it's closer to 0.19. And then the final question, cancel, fraction, pi, which is its own special symbol above the times 10 there, times 17 over 0.1. Move the cursor out of the fraction, plus square root, sorry that's cube root, wrong one. Square root is that one, 14. So pi times 17 over 0.1 plus the square root of 14. Two significant figures, it's either going to be 530 or 540. Next digit across is a 7, makes it closer to 54. So that's working with significant figures.